Hello, good day, viewers. You're welcome to today's class. I remain your tutor, Aisha Bindi. Today we shall look at oxidation number. We'll look at the definition of oxidation number and also state and explain about 9 rules governing the use of oxidation number in chemistry. So to begin with the definition, oxidation number is also known as oxidation state. It is a value assigned to an atom in a compound to represent its charge. The oxidation number indicates the value of electrons that are lost or gained by an atom when forming a compound. And as such, there are some rules governing the oxidation or the use of oxidation number, which we're going to look at today. We state each rule, then explain. So let's start with rule number 1. Rule number 1 governing oxidation number states that for any element on its own, the oxidation number is equals to 0. So what this means is that for any element standing on its own, for example, let's say carbon, the oxidation number, when we see carbon standing on its own like this, with no other elements attached to it, the oxidation number is 0. When we have nitrogen standing on its own, as we can see, no element is attached to it, the oxidation number of this element is equals to 0. So this is what the rule number 1 means. Any element on its own is equal to 0. Rule number 2 states that in the periodic table, all the elements that falls in group 1A have oxidation number of +1. So, example of elements we have in group 1A, we have lithium, we have sodium, we also have potassium. So for the third rule, it states that in the periodic table, the group 2A elements have oxidation number equals to +2. Examples of elements in group 2A are, we have beryllium, we have magnesium, we have calcium. Now moving to the fourth rule, it states that the periodic table, elements in group 7 elements are known as the halogens, such as chlorine, fluorine, iodine, bromine. All of these are elements in the period in group 7. They are group 7 elements. So they have oxidation number of -1. Chlorine, fluorine, bromine, iodine. All these are examples of halogens. So the fifth rule now is concerned about an element known as hydrogen. There are 3 things we need to know for hydrogen. So let's put this into writing. When hydrogen combines with metal, the oxidation number is -1. But when hydrogen combines with a non-metal, the oxidation number is +1. Then when hydrogen exists as a peroxide, for example, hydrogen peroxide, the oxidation number of hydrogen is equal to +1. So these are very important for us to take note. So moving on to the 6th rule. The 6th rule is concerned with oxygen. Usually, oxygen has an oxidation number of -2. But when oxygen exists as a peroxide, its oxidation number is -1. So let's put this into writing. So rule number 6 has to do with oxygen. Usually, the oxidation number of oxygen is equal to -2. But when oxygen now exists as a peroxide, its oxidation number is -1. Example, we have like sodium peroxide, we have hydrogen peroxide, and so on. Okay, so let's take notes, very important. Now, moving on to the seventh rule. The seventh rule states that the sum of individual elements in a compound is equal to zero. Okay, so let's put this in writing. So, for example, let's say we have a compound CaCO3. The sum of its individual elements, okay, that is, we have calcium, sum that means addition, right? Plus we have carbon plus oxygen, which is 3. The sum of these, the oxidation number here will be equated to 0. So that is what rule number 7 is talking about. So let's move on to the 8th rule. Rule number 8 states that for a simple ion, the oxidation number is equal to the charged ion. Let's put this in writing and explain. For a simple ion, so example of a simple ion, we have Al3 plus. So as you can see this, the oxidation number here, this is a simple ion. The oxidation number here, according to the rules, says that the oxidation number is a charged ion. And the charge here for this simple ion is plus 3. So that means the oxidation number of aluminium here is plus 3. Another example, if you have Ca2 plus, this is also a simple ion. The oxidation number of calcium here is the number of its charges, and the charges here is equal to plus 2. So that means the oxidation number is plus 2 here. Okay? So the ninth rule, number 9, it states that for a complex ion, we have the simple ion, we also have the complex ion. For the complex ion, the sum of its individual elements in a complex ion is equal to the charged ion. So let's put this in writing. So the sum of individual elements in a complex ion is equal to the charged ion. So example of a complex ion, we have MnO4 minus. This is a complex ion. So let's interpret this. What this means is that the sum of the individual elements, the elements we have that exist here, we have manganese plus oxygen, that is O4 here, right? So this is the sum of the individual elements for this complex ion. The size equals to the charged ion. So the charge is carrying here is -1 because this is minus. So that means the oxidation number here is -1. Another example, we have C2O4 2 minus. This is also a complex ion. So the sum of the individual elements in this complex ion is equal to the charge. So here we have C2 plus O4 is equal to, the charged ion here is -2 because here we are having 2 minus. So the oxidation number here is equals to -2. So this is what um, rule number 9 is all about. So, dear viewers, these are the 9 rules governing the use of oxidation number in chemistry. If there are other rules you know out there which I have not stated, kindly be of assistance and drop the rule or the rules in the comment section. We are here to learn and to educate ourselves, right? So if you have any question based on the 9 rules I've stated on the board today, kindly drop your question in the comment section for observation. Also, kindly drop your observation and your suggestions in the comment section, and we will appreciate it a whole lot. Thank you so much, my dear viewers, for your continued support. Remember, let's remain Aisha Bandi, and bye for now.